Financial applications on IB Math AISL. Here is the first part of the question, and here is the second part of the question. Make sure you have screenshotted them because I'm going to discuss in 3, 2, 1. For the first question, it is asking in two parts. The first one is the amount that it would be in the account of the first bank at the end of the first year. So this means it is asking for the future value, in which we can use the formula book from SL 1.4. We put the interest rate as 3% annually, and because it says compounding monthly, we need to use the K factor is 12. Solving that with GDC will get us into 87585. And for the second part, it is asking the same thing, but instead we're going with the second bank instead. So instead of having compounding interest, they use a flat fixed payment of $250 a month, which means we just add the present value with $250 and we multiply this with 12 months because we only want to see for 1 year, in which we get 88,000. Question B, we need to write two expressions. The first is the amount in the first bank after nth year. The second one is the amount in the second bank at the end of nth year. So it means that instead of putting 1 into the number of years, we use n because we might want to substitute with any number. We want to get the generic formula. For the b in the first part, we use the same formula and we change that into n, and then we can simplify that into as the first equation. For the second part, to multiply with n years because we only have 250 in the form of month. So we need to multiply with month in a year, in which it is 12, and we multiply with the n. So we expand it into 85k plus 3kn. C, calculate in the year which amount of the first bank becomes greater than the amount of second bank. So the concept is that compounding formula might start very slow if you see the exponential graph, and then suddenly it will become more steep. If we compare that with the linear, there will be a point where the compounding graph exceeds the linear graph. So we solve when the first equation is larger than the second equation. So we can put all the function here, and then after that, we can solve that with graphing, and then we find the intersection, and the intersection is 10.65 years. So it means that when n is larger than 10.65 years, the first graph is larger than the second graph. So this implies that when n is 10, it has not exceeded. So we need to have n equals to 11. Then the amount in the first bank would exceed the second one. So it will happen during the 11th year. For D, we also have two parts. We need to calculate the interest if she invested for 10 years, and also the second bank for 10 years as well. And we need to only calculate the interest amount. So first, the step is we find the future value, and then we subtract that with the present value. So first we can substitute n equals to 10 into the formula 1, which is the first bank. So we're solving that with GDC, and we will get it is around 114,695. And then subtract that with the present value to get the interest amount. So we get that the interest amount in the first bank for 10 years is 29695. Now for the second one, we substitute n equals 10 to the second formula. So we also expand that, and we will get 115k. Again, we need the interest amount. So future minus present value, and we get that the interest amount is 30k. If we invest that in the bank for 10 years, this implies that the second bank will give us more interest rather than the first bank. As we saw before, from 11 year onwards, the first bank would be much better because they have the compounding effect. For more IB Math tutoring, you can subscribe this channel and check the link in the description.